I'd like to conclude this module showing you some C++ code to build a simple slideshow demo using Cinder. During my trip to Bellevue and Seattle on September 2013, I took several photos and I liked the idea of doing a small slideshow application. So the first thing is to put these photos in the resources folder, since we want them to be baked inside the exe, so we can just distribute the single exe to family and friends without the photos alongside the exe floating around. Here is the resource folder with the photos inside. Now let's go back to Visual Studio. So here in resources.h we can use the Cinder_resource macro to list the resources, specifying their file name and their unique ID. As we can note, the integer Windows resource numbers start with 128 and go on with incrementing values. I chose to identify these resources using the res_slide1, res_slide2, and so on preprocessor defines. Then, in the resources.rc file, we need to list again the preprocessor defines used in resources.h to identify all resources. And there they are: res_slide1, res_slide2, and so on. Now let's go back to the C++ source code for our slideshow Cinder application. We start by the usual inclusion of header files to use classes and functions required in our application. We already discussed that list in previous demo. The only new entry is include vector. I added this line since I needed to use the STL studVector container in this application. The studVector container is a C++ container class that is part of the standard C++ library. You can think of it as an ordinary array that can be resized at runtime, that also knows its own size, unlike raw C arrays, and has some other useful features. Then we have the usual application class, derived from Cinder's AppNative base class. In this application, we implement the setup, keydown, and draw methods, which are virtual methods inherited from the base class. Then we have a couple of private data members. We build a vector containing GL textures. This data member is called mSlides. As usual, the initial m is my coding convention used to identify data members, and slides is there because this vector will contain our slides, that is to say, our photos. Since only one of these slides can be visible at any given time, I defined another data member, which is an integer. It represents the index of the currently displayed slide, indexed inside the vector. Note that studVector items have indexes that go from 0, for the first item, to number of items minus 1. So, if we have 5 slides, valid index values will be 0, 1, 2, 3, and 4. Number 5 is out of bounds. Let's have a look at the setup method. In this method, we load the images we want to show from resources. In fact, we use loadImage with loadResource, with proper slide preprocessor identifiers, as defined in resources.h. Note that the result of loadImage, which in this case is used to build a GL texture object, is added into the vector container using the vector's pushback method. So after all these pushback calls, the vector, which was created empty, will contain 5 GL texture objects, one for each of the image we want in our slideshow. Then, before leaving the setup method, we initialize the index of current slide to 0, starting the show from the first slide in the collection. Inside the keydown method, we process just 2 keys, the right arrow key and the left arrow key. When the user presses the right arrow key, we increase the index of current slide, preparing to display the next photo on the application window. However, we must pay attention when we arrive at the last slide. In this case, we just reset the current slide index to 0, going back to the first slide. Note that I used a static cast here, since the vector method named sides, which returns the number of items in the vector, in this case the number of slides, returns a type which is size_t. Size_t is an unsigned integer. Instead, mcurrent is a simple signed integer. So, using an explicit C++ style cast suppresses a compiler-issued warning about this signed and signed mismatch. And we have similar code to handle the case of user pressing the left arrow key. In this case, we decrement the value of current slide index pointing to the previous slide. And if we reached the first slide, the decremented value becomes negative, and so we move to the last slide. Note that the last slide has an index equal to the number of slides returned by mslides.sides minus 1. Again, the C++ style static cast suppresses a compiler warning about signed integer-unsigned integer mismatch. And then we have the draw method. As we can see, the body of the draw method is very simple. Here we just use glDraw, passing the texture corresponding to current slide. mSlides is the vector containing the textures. And we use the usual square bracket syntax to access the item in the vector with the specified index. In this case, the index is the value of mcurrent, that is to say, the index of current slide to be displayed. Okay, let's try to run this application. We can press Ctrl F5. And here it is, this beautiful view of Bellevue from the Westin. I press the right key, and then we have a view at night. I press the right key again, and then we have these big crabs at the Pike Place Market in Seattle. I've never found something like that in Italy. Again I press the right arrow key, and we have some big fishes as well. Pike Place Market is a great place to visit. And we have these beautiful colorful plants and flowers at the bottom of the Space Needle in Seattle. As you can note, we can move forth and back using the arrow keys. As a learning exercise, you may want to build your own slideshow demo with Cinder with your own photos and show that to family and friends. Enjoy!